Ah, there we go. Okay. All right, we're just going to adjust this so that, like, wherever I am, that's where the camera is. If we need to back it up, if we need to zoom out, we're getting, like, the whole board.
No, it's, like, directly above your head.
The important thing is, like, the board is the important thing.
Okay.
If I'm writing on this board's important. If I'm writing on this board's important.
See, that's the angle you need.
No, I think you can just...
So we have to extend the back ones and bring this one closer to bring the angle forward. Oh, okay.
Are we mostly okay?
Can you stand in front of the board?
Okay.
Okay.
It's not about me, it's about...
Why don't you just put it on one, put it on one desk.
Oh,
It's like-
no. Get like a stack of note cards or something.
All right, friends, let's wrap it up. So first off, for those of you that get a chance to do some extra practice last night, how did it go?
Good.
Get better? I care about the better. I care greatly about the better. Okay, so let's check that off the list. And a couple of quick things. Those of you that are interested in reassessing on that quiz next Tuesday, how many of you are planning to do that? Okay, good. I'll make sure I have enough copies. Remember, you need to stay after school with me either today or Monday to work on the corrections. I'm going to be available both days until 5 o'clock. Strongly encourage you to stay, one or both of them. The problem set that you're working on tonight, that's due tomorrow, is excellent preparation for that quiz. It's just more practice. There are no new things on there. It's just practice with the old stuff. We're good? David?
I started working on the back and forward.
Yeah.
And I was kind of conflicted because for 5 and 6, there's a way that Miss Ray showed us to solve it.
Uh-huh.
And there's like a way where you could do one step before the way Miss Ray showed us, and you would get like 0, 0.
Okay. Why don't you and I talk about that a little bit more later? Okay. I want to get rocking and rolling. So can everybody say hi to our friends at North Forest, Southeast, and East End?
Hi.
Hi, North Forest, Southeast.
Hi.
North Forest, Southeast, and East End. Okay. So here we go. Here's the good news. We are done with techniques for evaluating limits. I have no more ways to show you, right? We've looked at like finding limits by direct substitution. And that sometimes works. We've looked at like the algebra tricks where we factor and cancel. We get a comment, like we've done all of these things. We've also looked at like, do you know the parent function? And if you know the parent function, you know what to do. And we've done that like mental math thing. Like we've done all these different techniques. Those are all the ones that you need in order to be successful in AP Calc. This is good news.
Good news.
We are not worried about the camera. Don't worry about the camera at all. Okay, so what I want to do though is for the next couple of days we're going to look at like how are we actually going to use these limits to push your understanding of functions and calculus and get stronger. So today and tomorrow we're going to focus on asymptotes. Do we know about asymptotes?
They don't
We've
touch.
heard asymptotes. Something about they don't touch. I bet if I asked you to start rattling off some parent functions that have asymptotes. Who could give me some parent functions that have asymptotes? Nora, give me one. Get me started.
Tangent.
I'm sorry, what? Okay, x, one more time. What I heard was y equals tangent of x, right? You're always taking the tangent of something. That's an example. Tangent of x. Give me some more.
Y equals natural log of.
Y equals natural log of x. You can just put that down and stay there. Don't worry about it. Natural log of x. David, give me another one.
1 over x squared.
1 over x squared. Marvin.
X squared.
Ooh, y equals x squared. That's the parabola, right? Does that have asymptotes?
No, I just said so.
It heads off to infinity. If all it's doing is heading off to infinity at the end, that's not an asymptote. Thanks for bringing that up. I heard tangent of x, I heard natural log of x, I heard 1 over x squared. 1 over x has some asymptotes. Other ones? There are more. Secant of x has some asymptotes. Marvin? E to the x power? E to the x power, knowing me. Cotangent of x has some asymptotes, and there are more. What I want you to do, you've got 3 minutes. I want you to sketch on this paper as many parent functions that you know of that have asymptotes. Okay? In your sketch, be sure you are naming the function. I don't mean call it Bob. I mean like, this is the graph of e to the x. So what I want to see in your paper, if you're saying like e to the x is an example, Great.
Got him.
And for e to the x, where's the asymptote? One more time. Y equals 0. And the way that we normally indicate asymptotes, right, you do like a little dotted line. And so we're going to say that we have a horizontal asymptote of y equals 0. We've been here before. We've done this. Okay. Get as many as you can in the next 3 minutes. 3, 7, 10, 14, 17.
Anthony and Edgar. Edgar.
Eunice is on her 6th one. Adriana is on her 4th one. Remember, I want the sketch and I want you to label those asymptotes. Nora's on like her 18th one. Not really. You'll find out. All right, I want you to take 1 minute. I want you to have a group conversation. Compare all your parent functions. If your neighbor has something that you don't have, get it on your paper. You've got 1 minute. Make that master list.
How many are
I only put 3 so far because I'm not in there.
Seeing some nice curves out there.
It makes it crap. Okay.
I got 4. But those don't have asymptotes. Cosine of x. Oh, you need the right cosine.
4 too. Am I tripping?
Yeah, see what?
Hey, I need that packet. No, higher. Give me a copy of that. Ooh, how'd you fix the board that good, girl?
Gonna close out in 5, 4, 3.
How we missed it? I didn't miss it.
And 1. Okay, now that you've had an opportunity to check in with your partners, how many of you have at least 5? At least 5 parent functions. 6, 7, 8, 9. How many do you have?
12.
12!
Is that, I may be wrong.
Oh, okay, I got you. No, all right, we're good. All right. You missed the sketching part, but that's okay. All right, so let's make sure we've got a full set here. You should have graphs of y equals e to the x, y equals e to the negative x, and y equals natural log of x. Okay? At least those 3. Y equals e to the x, make sure you're indicating that you have a horizontal asymptote at y equals 0. I care greatly about seeing those little dotted lines. Are those dotted lines going to show up on your calculator? No. But the dotted lines are an indication of like what's happening as I head off towards negative infinity. I'm getting closer David, you asked me a question about, like, can we touch them? We'll find out soon. E to the negative x has a horizontal asymptote at y equals 0. Natural log of x has a vertical asymptote at x equals 0. You might want to make a note here. It does not have a horizontal asymptote. The graph of the natural log of x, it is increasing without bound. It just gets taller and taller and taller. No horizontal asymptote. Okay, some more that I want you to make sure that you've got, and I think most people have these. Graph of y equals 1 over x has vertical and horizontal asymptotes. 1 over x squared. And 1 over x squared plus 1, maybe this is the one that you didn't really know coming out of pre-calc, but we've talked about it a few times now. That's okay. These are the 6 I care greatly about. The 3 that I think you're really pushing for extra innings, if you've got these, the graph of tangent of x has a vertical asymptote at negative pi over 2. It has another one at pi over 2. It kind of looks like an S, but you've got to be careful with those vertical asymptotes. You've got secant of x and cosecant of x. We're up to 9. I'll leave these up here for a little bit. How many vertical asymptotes does the tangent function have?
Infinite. Infinite.
Trick question. Be careful.
Domain restrictions?
How many vertical asymptotes do you see, Adriana?
On that one?
On this one. For tangent of x, how many do you see?
2.
You see, everyone's okay, we see 2 vertical asymptotes. But you know something about the tangent function. The tangent function, it repeats, the fancy word for this?
Infinite. Oh, oscillates.
It's a periodic function. Right, the period is talking about how long does it take for the graph to repeat. What's the period for the tangent function?
Pi. No. Pi.
Right, you have a vertical asymptote at negative pi over 2. You have another vertical asymptote at pi over 2. What's the period? How long does it take to make that journey?
Pi.
Pi, and then it starts again, and it starts again, and it starts again. Okay, this guy over here, secant of x, how many vertical asymptotes? How many vertical asymptotes are there total? Like if I just keep going on forever and ever and ever?
Infinite.
There are infinitely many vertical asymptotes, okay? Now there's one special one. When I was walking around, I did not see it on anybody's paper. But I want to make sure that you've got this in your wheelhouse. Like you've got this stored. You've got it stored up for the winter like a little squirrel saving all the little nuts. Arctangent graph. This is an oldie but a goodie from pre-calculus. We have not talked about it much yet. This is a really good example for you to have. What makes this one so special? What do you see wrong here?
It's still the tangent graph. It's flipped horizontally.
It's got there's some transformations that have happened going from tangent to arctangent. I agree with that. It's a little too strong to say it was just flipped.
Yeah,
There's more to it than
you
that.
can't have.
There's something special about this, though. There's something special that none of the other parent functions have. Anybody see it? Look at that list. Look at that whole list. There's something really special about arctan that does not happen with any of the other parent functions that you see. Adriana, what do you see?
It has 2 horizontal asymptotes.
One more time.
It has 2 horizontal asymptotes.
Everybody see that? You've got 2 horizontal asymptotes. All the other ones have either 1 horizontal asymptote, examples that have 1 horizontal asymptote.
Y equals 1 over x squared.
1 over x squared has 1 horizontal asymptote. Another one? 1 over x, e to the x, e to the negative x, right? The arctangent has 2 completely different horizontal asymptotes. So I just want you to put a little flag next to that one. It's a special one. All right, everybody mostly okay? I've not taught you anything about asymptotes. This is stuff that you knew from back in the day. So let's keep on going, because I need to prepare you for college. Life is coming. A year from now, you're going to be on some amazing college campuses, and you're going to buy a calculus textbook that's going to cost you $300 for real. You're going to open it up. You're going to be like, hey, what do we know about asymptotes? And what you're going to be faced with is this definition. I need somebody brave. Somebody brave who is going to read out loud that first paragraph using good, strong notation. Abraham, nice and loud and proud.
As x approaches infinity, or as x approaches negative infinity, if the graph of y equals f of x approaches the horizontal line y equals L, then the line y equals L is called a horizontal asymptote of the graph of f of x.
Okay, stop right there. That is the textbook definition of a horizontal asymptote. Read over that one more time. Highlight anything that is really important, because that is the proper technical definition of a horizontal asymptote. As x approaches infinity, or as x approaches negative infinity, if the graph of y equals f of x approaches the horizontal line y equals L, the fact that we are approaching this line is important. Then the line y equals L is called a horizontal asymptote of the graph. Okay. And Abraham, can you call on somebody else to pick it up from there? Okay.
In other words, the limit of f of x equals L.
Hold on, how are you reading that?
Wait, what? As the limit of x approaches infinity of f of x
Of f of x.
equals the line y, right?
Wait, equals L?
Wait. Oh, that's what you call it? That's a variable?
That's the letter L?
Is that all it is? Oh, I thought it was okay, I thought because at the very top it says line y.
Oh, okay, no, this is just the letter L still. Okay, it's all right.
L.
We're on camera, don't worry about it.
Equals L. Then the line y equals L is your horizontal asymptote of y equals f of x.
Okay, I'm gonna let that one slide. Let's just get the whole part here. Here's the picture I want you to have in your head. Nora, thank you for being there for me. A horizontal asymptote looks like that, right? We've got some horizontal line y equals L. What makes a horizontal asymptote is what happens as x does what?
Approaches L.
Not L. What's x doing?
Oh, okay. Infinity.
As x approaches infinity, I'm getting closer to this line. So for example, my graph might look like this, right? Just imagine some function that as I head out to infinity, the function is getting closer to this horizontal line. Are we okay? Right? I'm sure we can think of parent functions that look like this. For example, just call them out if you know it. E to the x does not look like this.
Negative.
E to the negative x looks like this. Another one? A function that has this kind of behavior.
Parabola.
Not a parabola. Abraham? 1 over x has this behavior. Give me another one, Martyr. What? So I heard e to the negative x has this behavior. I heard y equals 1 over x has this behavior. Somebody else said y equals 1 over x squared has this. There's a lot that have this behavior. Okay? But what's happening, the notation that this goes with is the limit as x approaches, what are we approaching?
Infinity.
Infinity, and the function is f of x is getting closer to L. Now, I want to be really picky here. We're approaching L. The y values are greater than L. So I'm going to say it's the limit as x approaches infinity of f of x is equal to L, but I'm approaching L from the right because those y values are greater than L. That is an example of horizontal asymptote. But so is that. Right? It's possible that my graph is approaching L in this direction, and my notation here, I'm going to say limit as x approaches infinity of f of x is equal to L. My y values are less than L, so in the number line I'd be thinking coming from the left. It's possible that my graph looks like this. This is going to be limit as x approaches, what's the x approaching?
Negative infinity.
I'm heading towards negative infinity. My function is f of x. I'm approaching L still, and I'm greater than greater than that. Or my graph looks like this, limit as x approaches negative infinity of f of x is equal to L from the left. I want you to have a clear visual in your head of what we're talking about. Questions before we do anything else? I'll take anything from anybody. Ron Beer.
So for those two functions on the right,
Yep.
how if both of them are coming from the left, are we just saying the top one's coming from the right only because the values are greater?
Thank you. I want to clarify. This is like an or. I'm talking about the graph could look like this, or it could look like this, and I call it a horizontal asymptote. So, can anybody think of a parent function that has this kind of behavior? As you're approaching negative infinity, you've got a horizontal asymptote. Let's get some hands on this. Go back to that list. X is approaching negative infinity. Jennifer.
E to the x.
E to the x has this behavior, right? How about another one, Ron Bear?
1 over x.
1 over x has this behavior?
1 over x squared.
1 over x squared has this kind of behavior. Jose, you got another one for me? Okay, how about this behavior?
1 over x.
What about this one? 1 over x has this behavior. This behavior over here?
Natural log. Yeah.
Almost the natural.
The
log.
natural log graph, except something about the natural log. Natural log, no horizontal asymptote. No horizontal asymptote. Raise your hand when you can think of a graph that has this behavior.
Oh.
You have a horizontal asymptote on both ends. This one and this one. I'm waiting for some hands. I want hands. A function that does this. It's got this behavior. As I approach positive infinity and as I approach negative infinity, I see horizontal asymptote behavior. Uh-oh, no hands. Ron Beer sees it. Naomi sees it. Only 2 people. Nora sees it. Nora, give me a parent function that does this. It does both of these.
Would it be negative?
So it's a negative?
Okay, negative 1 over x would have this behavior. How about this behavior?
1 over x.
Right, it's possible to do both of these. How about these two?
1 over x.
1 over x squared, would you, right? These two?
Negative 1 over x
Negative 1
squared.
over x squared, these two. A parent function that does both of these.
You can't, because there's 2 y values in one spot.
Right, I'm never going to have a parent function that does this behavior because
It's 2 y values in one.
I've got 2 y values for the same x value. Some people call that failing the parallel line test.
Parallel line test.
The vertical line test.
Beast point.
Okay, there you go. All right, so here's the thing. I want you to say this with me. When we talk about horizontal asymptotes,
We're talking about horizontal asymptote.
we're talking about end behavior. Say it with me, North Forest. When we talk about horizontal asymptotes,
We talk about horizontal asymptote.
we're talking about end behavior.
We're talking about end behavior.
Why am I doing this? Why am I doing this? There's a reason. Not just because I'm sweaty. Why am I doing this?
Get it,
Adriana?
Is it because x is always going to go either to positive infinity or negative infinity?
I want you to remember we're talking about x approaching positive infinity and x approaching negative infinity. Oh my God, this is all on camera. Okay. Horizontal asymptotes, we're talking about end behavior. We good? I'm not telling you anything about how the graph behaves in the middle. It's talking about the ends. Just the ends. David, this is part of the answer to your question. Okay, Marvin, can you take us into vertical asymptotes?
As x heads to k from the right, or as x heads to k from the left, if y approaches infinity or if y approaches negative infinity, then the vertical line x equals k is called the vertical asymptote of the graph of fx.
Excellent. Calling somebody else to read the last paragraph.
You're on.
In other words, if the limit as x approaches k of f of x is equal to infinity, or if the limit of x, or if the limit as x approaches k of f of x equals negative infinity, then the line x equals k is a vertical asymptote of y of f of x.
Nice job. Okay, so let's get a nice little graph going over here. Talking about a vertical asymptote, right? What kind of asymptote?
Vertical.
Vertical. Draw a vertical dotted line at x equals k. Now, I know you guys know this, so I'm going to go a little faster here. Right, if I have a vertical asymptote, as I get closer to k, my graph has to approach infinity. That is one of the options. If I see behavior like this, if I see the graph is increasing towards infinity, we're all going to say vertical asymptote. But couldn't the graph also do this? Could the graph do that.
Yes.
And this guy over here?
Yes.
All the things, right? This one up above, we're going to say this is the limit as x is approaching. What's x approaching?
Infinity.
What am I approaching? X.
K.
K from the left. The function is f of x. What's the y value approaching?
Infinity.
Right, down here you talk about the x values. Over here you tell me about the y values. X approaches k from the left and those y values are approaching
Infinity.
infinity. For this piece down here, the limit as x approaches k from the left of f of x is negative infinity. Over here, limit as x approaches k from the right of f of x is positive infinity, and over here, the limit as x approaches k from the right of f of x equals negative infinity. Like those are your options. Just give me a thumbs up when you've got all the copy. If you have to go like you're gonna die, go. And we'll talk about this when you come back. Okay. We got a copy down? Okay. Here's what I want you to do. I want you to lock eyes on somebody else in the room. You've got 4 minutes to work with somebody who you are not sitting with right now. Your job is to discuss your answers to these 5 questions over here. Find somebody you're not working with. 4 minutes. Answer all 5 questions. Go work with them. 4 minutes.
Oh.
Leave the camera where it is.
I don't want to take it anyway. Come here, Jizzle.
The camera.
I want full answers to these questions.
Mariah, yeah. I'll go to you, Mariah.
Make sure you fully answer these questions. They're not yes/no questions.
Can a function have more than one vertical asymptote? Yes. The tangent one has it.
More than
Yeah.
one vertical asymptote.
We can just say the tangent.
Yeah, but what's our explanation?
Oh, it can because there can be more than one like x. It can go to more than one. Oh, that makes sense. Like you can have more than one x value. Like it can go to more than one x value.
Oh yeah.
It's just some yes right now.
Or number 1. So this okay, I was thinking about tangent.
Was Martyr?
Yeah.
Martyr, in a little bit, are you willing to take your roll back on
Can a
of
function have more than one horizontal asymptote?
driving the laptop?
No.
That's not okay.
Because, okay, this is what I was trying to say. Because it won't pass, doesn't it have to pass like the vertical line? It has to pass the vertical line test. That's why this one can and this one can't.
These should be yes and no with examples.
Number 1 does, but number 2 doesn't.
Okay.
How are you doing? Would it be helpful so that you can focus on the conversation for me to give you a copy of my notes? I'll start doing that tomorrow. So that way there, like when we're like working in class, take whatever notes you want to, but then just focus on like
Which one would we do?
The one that is just arctan.
And then 1 over x squared minus 1.
Are you okay?
Number 2, can a function have more than one horizontal asymptote? I say no.
1.5 minutes left. Full answers, yes and no with examples.
Wait, does the negative infinity to infinity apply to the x-axis or to the y-axis?
No.
I'm guessing on the A. Because
Isn't this one going from negative?
I mean, like, I'm pretty sure it's true because
Wait. We disproven this one. This one has 2 horizontal asymptotes. We said no.
Yeah.
Yeah,
She
but
just
in
said.
special case.
So yes.
Number 2.
Which one was that? Number 2. Which is yes.
is this intersection.
Arctan.
Oh yeah. No. Wait.
But they don't go up. If they have vertical
Miss Jordy.
they have to pick up somewhere else. That's when it's not next to the wall. If it has a vertical
Mr. D,
Yes, sir.
when you for the third question, when you say negative infinity to infinity, are you talking about the x-axis?
Yes.
Okay. The function which is continuous, which was infinity to have a horizontal asymptote.
All right, closing out in 5, 4, 3, 2, and 1. Here we go. Can a function have more than one vertical asymptote? If so, give me an example. David, can a function have more than one vertical asymptote?
Yes.
Give me an example.
Cosecant. I think CSE.
Okay, cosecant with all the trig ratios. It's always like the name and then like give me an angle. So cosecant of x. There you go. Good. That is an example. Other examples? Jennifer. Cotangent of x. Rambier, give me another one.
Tangent of x.
Tangent of x, right? Tangent of x, secant of x, cosecant of x, cotangent of x. Did I get them all?
There's another one.
There's another one.
Y equals 1 over x squared minus 1.
Oh, you were so good. Thank you for saying that one. Y equals 1 over x squared minus 1. You are just giving them away for free today. Excellent. I'm not actually like taking action on this right now. Number 2. Can a function have more than one horizontal asymptote? And the whole world said?
Yes.
Yes. And the example, Jonathan. Y equals arctangent of x. Thank you very much. Number 3, can a function which is continuous on the interval negative infinity to infinity have a horizontal asymptote? Think about it. Can a continuous function have a horizontal asymptote? If you say yes, it must be because you can think of an example. Continuous function that it has a horizontal asymptote, Jennifer. E to the power of x, does that have a horizontal asymptote?
Yes.
Is it continuous?
Yes.
Checkity check. Great. What else? Give me another one.
E to the negative x.
E to the negative x. David.
1 over x squared plus 1.
1 over x squared plus 1 is another fine example. Thank you very much, son. Number 4, can a function which is continuous on the interval negative infinity to infinity have a vertical asymptote? Marvin.
No,
Why not?
because it has to break down at some point. in the
It
x
has,
value.
like my car.
No, like it doesn't put. If it's a vertical asymptote, it doesn't have an x value.
Say that one more time.
If it's a vertical asymptote, it doesn't touch the next value.
If your graph has a vertical asymptote, your graph is not defined there. There's no way to get from this side of the vertical asymptote to this side of the vertical asymptote and be continuous. Are we okay? Okay. Can a function ever intersect its horizontal asymptote? If you don't like the word intersect, put in the word cross. Can a function cross its horizontal asymptote? Now I know some of you guys didn't get a chance to think about this much. Think about it. Can a function cross its horizontal asymptote? Think about it. Think about it for a little bit. Can a function cross its horizontal asymptote? How many of you would say yes? One person? 2 people? How many of you would say no? How many of you have no idea? How many of you don't care? Just checking. Okay. Can a function cross its horizontal asymptote? Is it possible for a function to do that?
Yes.
Does that function have a horizontal asymptote?
Yes.
Does it have a horizontal asymptote? Does it have a horizontal asymptote? I say horizontal asymptotes, you're thinking about end behavior. At the ends, David, is this graph getting closer to a horizontal line? Is the graph getting closer to a horizontal line at the ends? Yes. That dotted line is an imaginary line that's not actually there. It is guiding the behavior of the function at the end. I never promised you anything about the middle. So, the answer to the question, can a function cross its horizontal asymptote?
Yes.
Yes.
What's
Can a function
I
cross
knew
its
it.
vertical asymptote?
No.
Never. Never. And you want an example of a parent function? Don't have one. Okay. I truly don't have one for you right now. All right, sad news. Sad news.
Lit.
We only have 10 minutes left. I know, sad news. I just wish we had calculus all day long.
Same.
Oh, samesies.
Are you
Can't wait for college.
Truly, Rombeer, when people say, are you having a good day? I'm like, if I've taught calculus today, yes. I want you guys to take out your calculators,
It's been miserable in the summer.
which means I want Martyr to assume the position.
Oh, they got on camera. We got you, that's all.
Oh no. Martyr, come on over back here.
Oh, bars.
Okay, I want you to graph that function.
I feel like I was gonna jump on. My bad. Are you okay, Martin?
Y'all are the worst camera people.
Hey, bro, don't be judging us. So ratchet yourself.
Okay, and Martyr.
I didn't look twisted.
Okay.
It's
There you go.
nice.
And a couple things. Right. Okay, look at the button. And also,
He's not.
and that looks better. Okay. All right. And Martyr, I think I kind of set you up for success back there. And exciting thing, this is called progress, folks. Bam!
Don't tell me.
Nope. There it is. There it is.
Bro, I brought
I
the
got.
wrong
I have to
calculator.
find out now. I need to switch between the two. Okay, just give me a quick thumbs up when you've got this graph on your calculator.
I can't try through the Robin or mine.
Do we have to? Oh no, we don't have to.
Okay. Hit standard window, zoom standard. Okay. Question number 1. Is there graphical evidence of a horizontal asymptote? Do you see that the graph is approaching a horizontal line as we head off towards infinity and negative infinity? Everybody's okay with that? Naomi, what does it look like this graph is approaching? Well, as x approaches infinity, I agree. As x approaches infinity, but my question is, what are the y values approaching? As x approaches infinity, what does it look like those y values are approaching? It looks like they're approaching 0. Is everybody okay with that? Now, looks like, and that is what's happening, not the same. They are not the same in my world, right? You might draw in a horizontal line. For those of you that are like, but coach, how do I get my calculator to draw on the horizontal line? It doesn't. Right? We are talking about it's starting to approach it. It's guiding the behavior. I've got a horizontal asymptote. And Daisy, do you see evidence of a vertical asymptote? Vertical asymptote.
Yes.
Vertical asymptote, where do you see that evidence?
On the top one.
So I'm here? Like here's where you see the evidence? Okay, as we head out this way, right? My graph seems to be approaching infinity. So like maybe there's some vertical line, would you guys agree, like around here? I want you to keep in mind that whenever we talk about vertical asymptotes, we're saying vertical asymptote at x equals horizontal asymptote at y equals Martyr could possibly get fired twice from the same job.
What did he do?
I don't know. He's like playing with the mouse back there. Everybody, graphically speaking, I give you the graph. You're like, I see it. I see some evidence. Now that's nice, but here's where we need to be. I need to be able to give you a function like f of x equals 5x minus 10 over x squared minus 4, and I need you to be able to identify where they are exactly from this. And you've done this in Algebra 2, and you've done this in pre-calculus. I want you to have a quick conversation with the people near you. How do you find horizontal and vertical asymptotes from the function?
Oh, denominators.
There you go.
Don't talk to me. Talk to your neighbors. Martier, find a neighbor. There's 3 ladies over
You
here.
set that mug equal to 0, and then they like fold. Wait, but that gets us 2. But that's a negative 2. Plus 4, square root 4, 2, x equals 2. Oh, what if we break it down? So x plus 2, x minus 2. But then,
Closing out in 5.
but one of them still doesn't work. Make
3. And 1. Okay, friends, what do we remember about horizontal asymptotes, vertical asymptotes?
But it still doesn't work.
Adriana, what do you remember?
The vertical asymptote is when the denominator, you set it equal to 0 and then you solve for the x values, and those give you the vertical lengths for the vertical asymptote.
Did everybody just hear what she said? So what I heard you just say is to find the vertical asymptotes, you set the denominator equal to 0, and you solve that equation. Is this familiar? Okay, so if I do that, vertical asymptote, what I heard you say is set the denominator equal to 0, so x squared minus 4 is equal to 0, and solve it. Now, Rombier's group had a conversation about, like you said, break it down, but I think really the word you meant to say was...
Factor.
Factor. Okay, if you're a factoring kind of gal, a factoring kind of guy, great. You're going to get x equals negative 2 or x equals positive 2. If you said, well, let me take x squared minus 4 is equal to 0 and move the 4 to the other side, does that work? Sure, and then you're going to say take a square root, that's okay. And at this point in our lives, we always remember to write that plus or the minus. So x equals plus or minus 2. Anybody see a problem?
It's not true on the graph.
Yeah.
Abraham, what's the problem?
Yeah, that doesn't apply on the graph.
It doesn't apply in the graph. Rombier, why doesn't it apply in the graph?
Yo no sé.
We've got some graphical evidence over there, and then we've got some like algebra evidence over here. The algebra evidence says 2. The graph says
1.
1. I want you guys to hit Control T on your calculator.
Right.
Control T, that pulls up the table so that we can see the data table. So Control T, Martier. Control T. Look at that table.
But it says 2 is undefined.
Anybody seen some stuff in the table?
But now it says they're undefined.
It says undefined at x equals 2.
Yeah.
Anywhere else?
What the heck?
If you scroll up, Martier, if you scroll up in the table,
How?
just arrow up.
Says
You
undefined.
should see at x equals negative 2, right, undefined.
Again.
There is a difference between saying undefined and vertical asymptote. I want to say that one more time. There's a difference between saying undefined. It is not true that you have vertical asymptotes. What you have is that the graph is undefined. You could also call these candidates. I'm a big fan of calling these candidates. Right? If the denominator was equal to 0, bad news, right? If the denominator is equal to 0, I can't divide by 0, can't do that. So these are the places that I look for my candidates. It is not necessarily where they are, but it's where I look. Are we okay with this? Mm-hmm. Okay, so let's go a little bit further. Martier, you've done a great job and you're done, so I'm going to hit that button. I'm so excited I can make that switch happen. So here's what we do in calculus class. If you guys go back to your definition of vertical asymptotes, that calculator, that calculus textbook definition of a vertical asymptote always looks like this. For a vertical asymptote, it says we take the limit as x approaches, was it x approaches k?
For verticals?
For a vertical asymptote, if you go back, flip back page,
Yeah.
the limit as x approaches k of f of x, what does it have to be? If you have a vertical asymptote,
Infinity.
it says limit as x approaches k is infinity, but it could be positive infinity or it could be negative infinity. If either happens, vertical asymptote. Everybody still with me? The way that we're going to decide this, we're going to find the limit as x approaches 2 of 5x minus 10 over x squared minus 4. And we're going to find the limit as x approaches negative 2 of 5x minus 10 over x squared minus 4. That's how we're going to decide using our calculus. Do I have a vertical asymptote or do I have something else? And we've only got a little bit of time, so we're going to be strategic. I want these three good-looking groups of people to find the limit as x approaches positive 2 of 5x minus 10 over x squared minus 4. I want these three good-looking groups of folks and anybody else at home to find the limit as x approaches negative 2 of 5x minus 10. We're going to have to go real quick. I'm going to work both of them out on the board. Don't look up. Don't look at me. Just work it through on your own. All right, maybe I've plugged it in. Oh my gosh, 0 over 0.
Is 0 over 0? Yeah. Okay, so x plus 2. We could factor out a 5, bro.
You're so smart.
Hey. I got 5 over
5 over x plus 2.
5 over 4. Come on, Mariah. You're so smart. Bring that. Both of them got us the same answer.
Friends over here, are we getting 5 over 4? Hopefully a relatively easy one, right? Maybe you tried the plug-in, the direct substitution, you get 0 over 0.
-2.
Not an answer. What do we call that? 0 over 0? Indeterminate form. So like I do like some factor cancel and I get 5 over 4. Friends that are over here, if you tried the plug-in, you get negative 20 over 0.
Yeah.
Not an answer, but a sign to do some stuff. If you factor cancel over here, you get 5 over x plus 2. You plug in, you still get 5 over 0. Guess what? Not an answer, not an indeterminate form.
It's over 0. Oh,
0
okay.
over 0 is the indeterminate form. Number over 0, that's when you do like that mental math and you say, okay, well, if x is approaching negative 2, x plus 2 is approaching 0. If I take 5 and I divide that by something getting closer and closer and closer to 0, what happens? 5 divided by something getting closer and closer and closer to 0.
0.
It gets bigger. What are we heading towards?
Infinity.
Infinity. Now, either positive or negative infinity. One of these is the behavior, give me just a second. One of these is the behavior that you expect to see with the vertical asymptote. Which one? Vertical asymptote. Limit as x approaches k has to give you positive or negative infinity. So this is where we're going to close things out. What this tells you is that you have a vertical asymptote at x equals negative 2. What happened over here? You didn't get infinity. As you get closer to 2, the y values are getting closer to 5 over 4. They're getting closer to 5 over 4. But your graph is undefined. I think I just heard it. Or we'll pick it up tomorrow. What this means, you're not getting infinity. If it's not a vertical asymptote, but your graph is undefined, you have a hole in the graph. You have a hole at x equals 2. All right, at this point, we can turn off the footage.
How is it that although like we're solving out a value,
Yep.
our graph doesn't get it?
But that's the thing.
I mean our graph gets it, but it's not like the same.
No, you